So, all right, let's open with a prayer, please. All right, Father God, we thank you for changes in seasons, both in the earth and in our lives. And God, we pray that as we go into a new season, that God, you would be with us, you guide us, and you protect us. Father God, we ask for wisdom now as we continue to work on this algebra. And we ask it in Jesus' name. Amen. Okay. All right, so a couple of things to start with. All right, one is that I am making a change in your assignment. Okay, we've done two things to make the Chapter 4 testing fair. Okay, the first thing is, all right, normally we would be doing the chapter test. All right, this particular chapter test has only 2 problems. Right? But because of the nature of what they are, it's not going to show us what we want. You do need to do test 2 problem. It's the introduction of something that's needed for the algebra problems that we're going to do in chapter 5 and 6. Right? This is new material, but it's very straightforward. It's not tricky. It's just new. I've already shared this once, so you'll see that there. And then the other thing, to make up for the first test problem, I want you to do the review problem 3 and review problem 4. That is solving a three variable matrix. Okay, so these 2 things will demonstrate that you have understood the basics of the chapter. Right, that'll be this. And then this is new, something that you're going to need. It also would lead, if they had done it, this also leads to a 3 variable matrix.
Got it.
Okay, so the 3 of them are related. So that will be part of your work, is to do these 3 problems as the chapter 4 test from these 2 pages. Right, these are actually on page 170. Okay, all right, then I'm going to give you a test. We have modified it. We've cut the number of problems in half, and what we're doing is giving you a fair assessment for this particular work. Follow the directions. Right, the vocabulary is important. You should know what determinants are. Right, you should know what an augmented matrix or matrix is, and linear combinations, right? And then there's one that says solve, which means you can use any method you choose. And then on the back side, there's a 3 variable matrix to solve, and then this is one thing to graph, where you have I1, I2, and I3. You're going to have 3 equations. You'll write the equations down here, and then you'll graph it and show where the solution is. And if you remember, for inequalities, it's either above the line or below the line. Okay, so those are those. All right? Okay. All right.
Okay, always 6 problems.
Yeah. All right, so put those tests away, because we are going to move very quickly, and you are going to need your notes.
Let's go.
Okay. All right. 5.1 and 5.2 were relatively straightforward vocabulary, right? So what we're going to do is we're going to talk about 5.3. Okay, there's a lot of things I want to cover with that. Okay, the first thing is what this says. The discriminant does not include the radical. If you remember, for the quadratic equation, it's the opposite of b plus or minus the square root of b squared minus 4ac, all over 2a. Okay, I was talking with an Algebra 1 student that was struggling with the quadratic equations that they were doing. You know what the first question I asked him was? What? Have you memorized the quadratic formula? All right, that person's answer was no. And I said, it's no wonder that you're struggling with this. It's like trying to do the math without a pencil. You can't do quadratic equations unless you know what the quadratic formula is. Okay, so I'm hoping that all of you know that. If not, then you just need to take a day or so to just learn it. You try to write it, right? And then if you can't, you look out, see what you missed until you can write it from memory. Okay, but when they're talking about the discriminant, this particular part, the part that's under the radical, will tell you something about the answers. Okay? Now, there's three things. This is in the book. There's three things that you can learn from the discriminant. If this value is negative, then you know that the parabola itself does not touch or cross the x-axis, so there is no real solutions. And I want you to underline real solutions. Because what you get in Algebra 2 is you start dealing with the imaginary solutions. And the imaginary solutions are going to have an I with it. And the I represents the square root of -1. And so if this is negative, then what you're going to do is you're going to pull the -1 out and change that to an I, because the square root of -1 will be defined as I, and then you're going to work with the number as if it were positive. Right? And so now in Algebra 2 we're going to work with positive real numbers and imaginary numbers. So if this is negative, you're going to have an imaginary, which means no real solutions. If it's a perfect square, then you're going to have a rational number. Because this is all over 2a, so it may be a fraction, but it's going to be rational. If it is not a perfect square, you're going to have an irrational number. And you should remember that rational numbers can be represented as a fraction. Irrational numbers are roots that cannot be, that don't produce whole numbers. An irrational number is a square root that's not perfect, or a root that's not perfect, and so it doesn't produce a whole number. And those particular decimal values in the calculator will round off to the 7th or 8th place, depending on your calculator. But technically, an irrational number continues indefinitely without repeating. Okay? And one of the things that we used to do in Algebra 1 is if you had the 0.33333 repeating, is that rational or irrational?
Rational.
0.333 repeating all the way.
Rational.
Rational, why?
Because it repeats. It can be pentagonal.
A repeating decimal is rational. It happens to be 1/3 or 3/9. Right? And so if it's a non-repeating continuous, that's what the irrational ones are. Okay? So they're going to talk about the discriminant. That should be pretty straightforward. Okay? Now, in quadratics, this is the important part, is the vertex form. Right? The vertex form is in two ways presented, as far as I'm concerned. The first way, this is the technical way. It says y minus k, and I'll explain that in a second, equals some value a, most of the time this is 1, times x minus h squared. Because that's a squared, this is a quadratic equation, right? One number is first power, the other number is second power. Okay? Now, if these are negative, then the vertex is an x of h and a y of k. So it's going to be the opposite of the number that you look at here and the opposite of the number that's inside the parenthesis. Okay? Now, that's the traditional way of representing it. However, most of the time, you see the y represented as f of x. So what happens is this k is added to both sides, so it ends up on the other side.
Got it.
Right? And so if the k is over there, then you have a times x minus h plus k, and then the opposite of the number inside, the same number outside, produces the vertex. Okay? Now, this form, you actually use more than this form. Because this form comes out in the things that we're doing with quadratics, where this is just a traditional. It's like the point slope method, if you remember that from last chapter. Point slope is similar to this, right? Except there's no a and there's no squared. But the point, there's a slope here, right? But the point is the same as these two. However, you rarely see it that way. Right? That's the problem with it. Okay? So that's the vertex form. All right. So let's talk about that just briefly. If I can bring this up. Okay. So here is a traditional vertex form. What's the vertex of the parabola for this one here? You're supposed to use the opposite of each number. So the opposite of this is what? Negative 2, 3. So negative 2 comma 3 is the vertex of this parabola. And because there's a 1 here, we're going to talk about that in a second. Because there's a 1 here, it's very easy to plot. Okay, now, what's the vertex of this second one?
Negative 7, positive 8.
Wait a minute, x first.
Oh, so it would be
Positive 5,
comma
negative
7.
Wait a minute. Now this one is not opposite opposite. This is opposite same. Right? Because this would be negative 7 over here, and so the opposite of it is positive 7. So this will be 5 comma 7 is the vertex. Now this particular number tells you about the size of the parabola. This one is 3 times bigger than this one. So it's going to stretch 3 times higher than this standard one does. Okay. And that's the other part that I'm going to teach today. Okay? Now, what is this?
The
quadratic formula. What's interesting about the quadratic formula, that right there is x. This right here is the same as that negative 2 or that 5. Okay. Now, how do I find the y value? You have to take whatever this value is and replace the x with that number, and you will get the y value. All right, so if it's in this form, it's much easier to find the y value. But if you had your calculator out, you look at the opposite of b over 2a, and then take that value and you're going to square it for the x squared, and then you're going to have it times some number times x, and then plus the c, and you can actually find what this is going to be here. And there should be another parenthesis out there. Okay? All right, makes sense? Now again, this part is review. I don't remember whether or not negative b over 2a is in Algebra 1 or not. Whether it is, this is something you need to know. So that now, here's another thing, which I didn't put down here. If you have a parabola, vertex is right there, in case you didn't know that. All right, now, what is this line that I'm drawing now?
It's the symmetry of the axis of symmetry.
It's the axis of symmetry, right? The value of the axis of symmetry is x equals negative b over 2a. It's also the same as the x value of the vertex. Right? So if you have the vertex, let's go back to this here. What's the vertex of this particular equation? Negative 2, 3. What's the axis of symmetry? X equals negative 2. It's just the value of the x value of the vertex. All right. So what is the vertex of this? Opposite. Same.
5, 7.
5, 7. All right. What's the axis of symmetry?
7.
is x equals, what does x equal?
Negative b over 2a, right?
What does x equal?
5.
5. X equals 5.
Value of x.
All right? Now, had we multiplied this out, we would have had 3x squared, and then this is 10 minus 30x, and then 25, 75, 75 and 7 is plus 82, if I got that right. And so now here you'll have negative 30 over 2a.
Right.
What is negative 30 over 2 times 3? Negative 30 over 6
6 is 5.
is 5. That's where the 5 comes from. All right, does it make sense? So, if given in the vertex form, you're going to just use opposite and same, right? Given this form, we're going to use the opposite of this over 2 times this.
Right.
Okay, does that make sense? All right. So that makes that a whole lot simpler in a lot of ways, but not necessarily easy, but certainly simpler.
No, not easy. Not easy.
Never.
All right.
Never.
So, questions on that?
I think I have one.
Go ahead. What's your question?
For the first, we said the axis of symmetry for the first equation was 2. Why was it 2 instead of negative 2? I'm sorry I missed that part.
Because it's the opposite of the b value, but it's the value of the vertex. So what's the vertex here? It's the opposite of this and the opposite of this. So the vertex is negative 2, 3.
3, right?
The x value is the axis of symmetry. So x equals negative 2 is the axis of symmetry.
Okay.
Oh, it is negative 2.
It is negative 2, yeah. Yeah, I had the negative right there.
Okay.
Okay, makes sense? Now, if we multiply this out, all right, this is going to give me x squared. I'm going to have plus 4x, and then I'm going to have 4, 5, 6, 7 plus 7. All right, negative b over 2a is how much?
Negative 2.
Negative 2. That's the same thing that we got from this one.
Got it.
Okay. All right, now. Okay, good question. Now let's see, we go here. All right. Now, so what we're going to do now is that we're going to talk about completing the square. I've got to. Where's my? There it is. Okay, completing the square. How many of you know how to complete the square?
I think so.
All right. Two
so.
remember, 3 are,
I believe so.
I believe
and 1's asleep. Okay? Okay. All right, now, here's what's interesting. Completing the square is easy when the number is even.
Right.
All right? It's easy when the number is even.
Facebook hates us, so we'll never
Okay?
forget that.
All right? Now, if you will work with a fraction, it's actually easy when the number is odd.
Oh,
Okay, and we'll discuss that. But for right now, what you do to complete the square, the easiest way is you take the first 2 numbers in the trinomial. This is a quadratic, if you remember. We're going to take the first 2 numbers.
yes.
Now, underneath that, what I like to do is put my parentheses in my square, because I'm going to make a perfect square using those first 2 numbers. Okay? Now, because when I take x plus a times x plus a, I have what on each of those curved lines? I have ax and ax. So how many ax's do I have?
2.
Dosos, right? I got 2, so therefore this number has 2 in it of whatever a and x are.
Wow.
So therefore, all I do is take half of that number. And I have x minus 7 squared.
Wait, hang on.
That's it.
I love
All right, now, we have a problem we have to deal with. Because this is Algebra 2.
Oh, no.
Right? Now, if I multiply this out, I'm going to have 3 terms. I'm going to have x squared. I'm going to have 2 negative 7s, which is negative 14. But I'm also going to have 7 times 7, which is 49.
it. Wait.
7 times 7 is 49.
You're right.
Yeah,
Okay? Now, because this that now listen, this is important. Because this that I just wrote has a positive 49 in it, then I've changed the problem unless I put a negative 49 in that side also.
Whoa. Remember.
All right, you see it?
Yep.
Okay, this is a trinomial. 7 times 7 is the third number in the trinomial, but I only use 2. So that means this has a positive 49. I have to put a negative 49 in order to keep a 0 change.
Yep.
Now I add those two together. And I get plus 4. Now what's the vertex? Opposite, same. So the vertex is now at 7, 4.
Whoa.
But that's it. That's it.
I love this.
Okay.
For now, until I'm
It's not hard. See, it's not hard.
Really hard though.
All right, but the thing that you got to remember is how many parts of this binomial square did we use up here? We only used 2 of them. This has 3. If you don't deal with that third part, then you change the problem and you won't come up with the right answer. But if you deal with whatever this number is squared, that's all it is. Whatever this number squared is always positive, provided that this is not negative out here, right? And so because this is positive 49, I just do negative 49 to make it come out to be 0 change.
I love it. I love it.
Okay? Now that to me is easier than trying to break this thing free,
Very true.
right?
Yes.
So now, if some people put the 49, you have this positive 49, they put a positive 49 on the other side of the equation. That doesn't make any sense to me because almost all of the quadratics say equals 0. So I don't want the number over there, I want it over on this side.
Right.
Does it make sense?
Yes.
Okay. All right, so now let's look at this one. All right, what do you see? All right, what am I going to do? I'm going to make a parenthesis squared. All right, what do I do to make the binomial?
Take half of 2.
Half of 2, which is?
1.
Negative.
Negative.
Negative 1 or positive 1?
Positive.
Positive.
Okay, just check. All right, so that's x plus 1.
But then
Okay.
you're gonna have to, you add.
Now, what is the third term of this trinomial?
It'll be 3.
It's 1 times 1, isn't it?
Oh, so once you add 4.
So there's a positive 1, because if I multiplied this out, I would have x squared, there's 1, there's 2, plus 2x, plus 1, which is 1 times 1.
Whoa, what?
So, all right, see, 1 times 1 is 1. Was that hard for you?
No, I heard it all and I was writing a little bit.
Okay, you see that? X squared. Now, these two right here, I've already got. But look what I added.
Okay, I got it
I
now.
added a plus 1, so unless I add a negative 1 to make 0, I've changed the problem.
Right.
So therefore, I put a negative 1 here, and that's going to make that negative 6. All right?
Gotcha.
Okay? All right, so now we're going to come back to those, but right now, that's all it is. That's all the skill of a 1x squared as far as doing completing the square. That's it. That's all it takes. Okay? So that part should be simple. And most of what you're going to see are going to have that in it because most of your quadratics are going to be 1x squared problems. However, to make your algebra harder, they have some that are not. Okay?
Unfair.
I'm ready.
Unfair. All right? Okay, now, but what we have to do before we do that, let me see if I can figure this out here. Here it is. Is that it? Boom. Okay, isn't that sweet? I didn't want you to see that. I didn't want you to see that. Okay, now we're going to go back to vertex from the vertex form. This is what we did when we completed the square.
So 7.
Right? And now, I added the 1 there for a reason.
Right.
Okay? But this was the completed square. So now, what is the vertex?
7, 4.
Opposite of this, same as this, 7, 4. So if I go to 7, 1, 2, 3, 4, that's the vertex.
Lovely.
Is it 7x?
What?
Is it 7x?
Thank you. Thank you. Thank you.
Thanks for saving us all.
Okay. 1, 2, 3, 4. All right?
Wait.
All right. So yeah, because it's x of 7, y of 4.
Yes.
All right. Now, when this is 1, the parent graph is y equals x squared. That's the parent graph. This is just one of the children of this parent graph. Okay, now, as long as this is 1, if I change the x1, what is 1 squared?
1.
So therefore, if I go over 1, I go up 1.
Right.
All right, what is negative 1 squared?
1.
1. So if I go back 1, I go up 1. Those are on the graph. Now, what happens if I go over 2? What's 2 squared?
4.
4. So if I go over 2, I go up 1, 2, 3, 4 from the vertex. If I go back 2, what do? Up 4. 1, 2, 3, 4.
Look at my little parabola.
Now, what would happen if I went over 3?
You have to go up 6.
No, 9, up 9, right? And in most cases, that's going to take you off the board unless I give you unless I give this as a negative value, so it's down where we have room. Okay? And so this becomes my parabola.
Look at the parabola.
All right, now.
I'm loving mine, guys.
Okay, now I'm going to give you, this is a test-taking skill. All right, if from the vertex you go over 1, up 1, and you're on the graph, over 2, up 4, then you know that this was a 1. Okay? Now, we're going to see some that are not 1, and we're going to find out that if this is not a 1, then if I go over 1, I'm going to go up 1 times whatever that number is.
Right.
And if this is greater than 1, what it's going to do is going to jump up farther, and so it's going to stretch, and this is going to get skinny. If this is a fraction, then I'm going to go up 1 times the fraction, which means I've compressed it down. I'm not going up as far, and so that's going to look fat. So if this is a fraction number here, it's going to be short and fat. If it's greater than 1, it's going to stretch it and make it skinny. If it's negative, it's going to flip it over.
Well, goodness gracious, you're just working these parabolas to death.
All right, you see what I'm saying? So, but the vertex is the same. The vertex works here. This particular value here is just an extra problem, not problem, let me say, it's an extra change on the parent graph.
Gotcha.
Okay, so let's look at this one.
But
Is this a parent graph? Yes, because the A is 1. So where's the vertex?
it is
Negative 1,
Negative 1,
negative 4.
Negative 1 and
1, negative 4 is right here.
Doesn't change.
All right, now, so now here's the thing. Over 1, up 1, because 1 squared. Over 1, up 1. Over 1, up 1 is here. Back 1, up 1. Over 2, up 4. 1, 2, 1, 2, 3, 4. 2, and notice because this is the axis of symmetry, I'm going to be right there. Okay? Now, over 3 up 9. Well, this was 4, so that means I got to go 5 more. I'm lazy, so I'm going to use a little bit of algebra. Okay? All right? Now, okay, so now this is the graph. All right, now, I'm going to show you with this. Let's take this and let's say it was 1/2.
Oh my man.
Okay, now what I'm going to do is I'm going to demonstrate to you what you say to yourself. Okay, so first of all, my vertex doesn't change; it's right here.
Right.
Now, over 1 up 1 times 1/2. What's half of 1?
0.5.
So it's 1/2.
Oh, okay.
So therefore, they're right there.
Cool.
Oh, I see how
Okay, over 2 up how many?
4.
4. Half of 4.
2.
So over 2 up 2.
Oh,
That's not as bad as I thought.
No, that's good.
All right, this will be a little tougher. Over 3 up 9. Half of 9.
4.5.
4.5, right? So I go over 1, 2, 3, and up 1, 2, 3, 4.5. All right, let's do one more. Over 4 up.
8.
Oh no, square.
16.
Square. 16. Half of 16.
8.
8. So over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, what do you notice about the graph?
It's getting wider.
It's fatter.
It's
All
fatter.
right. Now, unfortunately, they don't call it fat. What they've done is they've taken the blue one and they've compressed it down. So this is called a compressed. It's called compressed. Now, if this would have been 3, and we're going to see that in a minute, if this would have been 3, then I would have gone over 1 up 1 times 3, which is over 1 up 3. Over 2 up 4 times 3 up 12.
Oh my gosh, understand.
That's all it is, right? The graphing of a quadratic equation is pretty straightforward if you understand what the parent graph looks like. Okay? Now, we used to, in Georgia, we used to teach this to the 8th graders.
Oh, I did not know that.
Yeah, they stopped doing it. They stopped doing it. Back in the early 90s, they changed it. But when I first started teaching in the middle school, we taught the 6 different kinds of graphs to the 8th graders so that they could see the graph and know what the parent graph looked like.
I wish I learned that.
I wish they still did that.
Me too.
Me too.
Right?
I would
Okay.
learn so much more.
All right, now let me erase the board because we still got a long way to go.
Oh, see? O2.
Okay, now when the x value has a coefficient of 1, all of this works pretty easy. Okay? The hardest completing the square occurs, see if I can get it here, when it's not 1. Okay? All right, now, I need you to pay attention. I'm going to start over here.
Yes, sir.
Okay.
All right, this is by far the most difficult
Oh,
Yay.
because every modification is in this particular problem. Okay, now here's the first thing. I need a 1x squared in order to do my completing the square. This is not 1x squared, is it?
Right.
So I'm going to factor out a negative 1/2. When I factor out a negative 1/2, now this is going to become x squared. So I know that I can start here. Now, here's the hard part. What is a number that, when I multiply it by negative 1/2, I end up with 44? This is the hard part.
Wait, what did you say again?
All right, I'm going to factor out a 1/2. If you'll notice, 1 times negative 1/2 is negative 1/2.
Okay.
What number goes in here? this number times this has to equal 144. Well, what's half of this? 22. So if I have a 22 in here, right, then when I multiply negative 22 times a half, I get... No, I don't.
No. 11.
I get 11, so I went the wrong way.
Yeah.
So that makes this 88.
Yay, it's wrong.
You say no.
88.
Okay? Now, what about the sign?
You
To get a negative 44,
do positive.
this has to be a plus.
Here.
Because I'm multiplying it by,
It makes sense.
okay? Now, all right, now that's the hard part.
Wait, really?
But, so now what am I adding? The number I'm adding is a large number, right? Okay, so we're not going to see that often, but what I wanted to show you was that's the hardest. This one right here is what you'll normally see. All right, I need to pull a 3 out.
Okay.
Okay, if I pull a 3 out of this, what am I left with? X squared. Okay, pull a 3 out of this. Negative 6x. All right. Now, to be able to make the binomial square, I want half of the 6. 3. So that makes this x minus 3. All right. Everything's the same so far, right? Now, what is the extra term that I've added? 3 times 3. 9 times 3. I've added a 27, so I need a negative 27. It's this 9 times this number. Now, it also worked on the other one, but this number, before the number was 1. So when I had a 7 here, I went 7 times 7 is 49. 49 times the 1 was still 49. Yes?
And
Yeah.
would you have the negative 7 on the outside of the x minus 3 squared?
These two have to get added together, which is going to be
Oh, they can, okay.
plus 2.
Got it.
Right? See, these two are added together to become plus 2. All right, now, let's look at the x value. The x value is going to be 3, right? Let's use negative b over 2a. What is the opposite of b?
18.
18. Positive 18 over 2 times this.
6.
What's 18 divided by 6?
3.
It's 3.
Lovely.
So it works.
Yes, indeed.
Okay?
Yes, sir.
And so if you're trying to complete the square and you're not quite sure that you've got it, use negative b over 2a and see if it's the same thing. Now, if we put a 3 in here, this is 9 times 3, 27, minus 18 times 3 is what? 54? 27 minus 54 plus 29 is going to give me the 2.
Fabulous.
Right? So, all right, so that's the reason for learning the negative b over 2a, is that if you're not sure on this, then you can find it a lot faster. All right, now, where's the vertex?
It's
Opposite? Same. 3, 2.
I was going to say that.
All right?
Don't be wrong.
Yeah, I was going to say, I had to think it out, make sure I wasn't wrong.
This is how I really right.
Okay? So, oh, look at this. All right, so where do we plot this? We plot at 3, 2.
Right.
All right, now, I have a multiplier of 3. Over 1 up 1 times 3.
Right?
Over 1 up 1, 2, 3. And then back 1 up 3. Over 2 up 4 times 3. Over 2 up 12, which can be way up here. All right, so my graph looks like this. Now, if I was doing it regular, all right, so what do you notice about this graph? See how skinny it is? It's been stretched up. It's been stretched up. Okay?
Fabulous.
All right?
What are those dotted lines for?
That's the parent graph. That's the parent graph. Good question. All right, I should have said that. That's the parent graph. I see, because I had 1 and 4 and 9, so that's what the parent graph roughly looks like. And this is what our regular graph looks like, with the fact that I probably did not do a great job. But the relationship between how skinny this is and what the parent graph was. Now, if this was 1/3, all right, I'd be over 1 up 1 times 1/3, which would be way down here. Very hard to do because the size of my pen is about the same width as. And then over 2 up 4. 4/3 is 1 1/3, right? So over 2 would only be up here.
Oh my gosh. That's
Right?
fantastic.
And then what you're going to have is you're going to have a very skinny graph for the times 3, and then you're going to have a very fat graph for the 1/3. And it's important to know that, because visually, when you look at this vertex, you check over 1 up 1 and see if the graph is on that point. If not, then this is not a 1, it's something else.
Right?
And so if I go here, if I go over 1 up 1, 2, 3, then I know that the 1 was multiplied by 3, and I'm looking for this in my answer key.
Gotcha.
All right, does that make sense?
Yes, sir.
Okay, all right. Good. Now, 59. I went through really fast. Okay.
Good job.
All right. All right, on your paper, write the quadratic formula, please. Write the quadratic formula. When we start in Algebra 1 to learn this, it's all over what? All over 2a. All over 2a. Now, if you'll notice, all the letters, the A, B, and C are all inside the square root.
Yes, they are.
Right? B squared. Now here's a trick. What happens when you square B? It's always going to be positive. So in your calculator, do not use negative B squared in here.
Right.
Just use the number squared, because if it's negative, it's still going to end up being a positive value. The calculator, if you put negative B squared, this in the calculator is a negative answer, which is not what you want. What you wanted was this. Right now, if you want to put all 4 of those terms in your calculator, you can. You have to use the opposite of what the B number is here.
Right.
But this is just going to be B squared, whether it's positive or negative. If you understand that as a math student, that'll make this faster in your calculator. If you don't understand it, you're going to end up with something like this, negative B squared, and it's not the right number because the calculator is stupid. The calculator does not understand you. Right? So what it's going to do, it's going to square B and then make it negative. That's not what we want in here, is it? Right? We want a positive value. So if you know that it's positive, either put the parentheses around it or be smart enough to realize you can't throw the negative here. Right? Now, this is opposite. So if the value of b is a negative value, this becomes positive. Now, I have looked at solutions for quadratics. And if you understand that this negative value comes from the b of the quadratic equation, and you look at the answers, you can throw two of the answers out immediately. Because they're going to have the wrong sign on this b. Hear me? Right? So when you again, if you have four answers, and they're saying, what is the answer or what is the solution to this particular quadratic? If you'll look at the first number, it has to be the opposite of whatever that second number is in the quadratic. If it's not the opposite here, then you know that's a red herring, it's a wrong answer. And two of them you'll throw out immediately. And then you'll look under here and look at the discriminant, and you'll try to see who's messed this up. Okay? And one of those two has got this wrong. Okay? All right, does that make sense?
Yes, sir.
Okay, now,
Yes.
all right, let's turn to page 187. 187. Yeah, get your calculators out too, because I'm going to try something with you guys and see if we can do this. Okay.
Are you?
Okay, now, the first thing that we're going to do is we're going to look for the vertex.
What problem are you in?
We're going to look at number 9.
Awesome.
Number 9. First problem on page 187. Okay. Somebody want to help Ruben get to that page? You got it? Okay. All right, now. Okay, the vertex has an x and a y. Is problem 9 in vertex form? The answer is no. Okay. So we have two choices. We can either make the vertex form by taking half of the b term. All right? I don't want to do that. There's too much work there. So what will the x value of the vertex be? It's going to be negative b over 2a. So what will that be in this problem? It's going to be negative 9 over 4, isn't it? Negative b, which is negative 9 over 2 times 2. All right? Okay, now, if that's the value for x, I have to replace it in this equation to find the y. So what I'm going to do is 2 parentheses, negative 9 divided by 4, parentheses squared, plus 9 times, parentheses, negative 9 divided by 4, minus 5.
Wait, and this is all to find the y value?
That's to find the y value.
Oh my.
It's just calculator work. Put it in the calculator.
Gotta write it down.
You put the whole thing in the calculator.
Is that a plus sign next to the 9?
This is a plus, that's a times.
Okay.
That's a times. Because, see, it's 2x squared plus 9x minus 5. And we found that the x was negative 9 over 4. Now, is this ugly? Without a doubt.
Okay, for sure.
Without a doubt it's ugly. But the calculator doesn't care. Say, Chris,
Negative 15.135? Is that it?
I don't have any idea. I thought it should end with it should be a terminating decimal because it's in the fourths. I've got to
I
put
might
it
have put it in wrong.
in. You see what you did wrong?
No, I was saying I'm
let's try it.
I got negative 29.75.
Okay, that sounds better. That sounds better because it's got to have a quarter in it.
Yeah.
Okay.
Did you have the parentheses around the?
So 2. Yeah, you have to have the negative 9 divided by 4 in parentheses before you square it, and then plus 9 parentheses negative 9 divided by 4 minus 5, and I get negative 15,125. If I did it right.
Oh wait, that's what I did.
That's what you
That's
know.
the same answer I got.
Yeah, negative 15,125. Okay, now 125 is 1/8, by the way. So that makes this negative 15 and 1/8. Because 125, now you would have probably put 0.125, and what is negative 9 divided by 4?
Let's see, negative 9 divided by 4 is negative 2.25.
2.25, it's just, right? It's dividing this, goes in 2 times, 1/4 left over, and you should know 1/4 is the same as 1/4.
Yes, sir.
Okay? Now, all right, watch this. Put a 0 on the end of that 250. What's half of 250? 125. Half of a 4th is an 1/8. Again, that used to be 8th grade. But they stopped doing that last 20 years.
Praise.
Right? See, and so, see what happened, what used to happen is that in 8th grade and some in 7th grade, is that you had the skills which helped you when you got to Algebra 1 and Algebra 2. Right? And it was called pre-algebra.
Pre-algebra is not.
Right? Now, see, they changed pre-algebra, and so the skills of being able to understand how these are related, so that so the numbers don't look so scary, you didn't have a year's worth of practice at it. Right? And so all of this is scary and all of it's tough.
Yes.
Right.
Okay, but it's not past you doing, because you guys are smart. Okay, all right. Okay, so what did we just do here? Okay, we found the vertex,
And then we found y.
right? And well, in order to find the y, all we found was the x of the vertex.
Right.
Now, so if I asked you what's the axis of symmetry?
The x.
Which one?
Axis of symmetry for this problem.
It would be-
Remember, the axis of symmetry is just the x value.
So it'd be
Right?
negative
So
9
it's
and 4.
x equals negative 2 and 1/4, if I want to put it that way. Negative 2.25, or I could have said x is equal to negative 9/4. Yes?
That reminds me, some of the problems were asking for like the symmetric point, and I had no clue how to find it.
Symmetric point probably means the axis of symmetry.
No, it was like across from the y-intercept. It was like a point on the parabola across from the y-intercept. And I
Show me that later, okay? Or do you have the page number?
No.
Okay, all right. Let's talk after class, because I'm not familiar with what you're asking, but we'll get that answered. Okay. All right. Now, so that's problem number whatever it was, 7. 9. Problem 9. Okay. So problem number 11. Problem number 11. What's different in problem number 11?
Wheel. It is in, what's it called? Vertex form.
Okay. All right. Do you notice that there's no c value?
Yes.
What is the c value?
1.
Oh no.
0.
0.
0.
Because it's not there, right? So the c value is 0. So what's that going to do to your quadratic equation? It's going to make the square root of negative b plus 4 times 0.
Whoa.
So it's negative b.
Right? Negative b squared, right? And so this will turn out to be much easier to do. All right? Now, problem 13, we're going to do a vertex form because it's set up that way.
Awesome.
All right, so problem 13, put it on your paper. 4x squared minus 12x plus 9 equals 0. Okay. All right, the 2 steps is get the x squared to be 1 and then take the half of the second term. So in order to be able to make a 1 here, what do I have to factor out?
4.
The 4. So when I factor the 4 out of here, I have an x squared minus, take a 4 out of the 12. 3. Now let's double check. Multiply it out. 4 times x squared.
4x squared.
4 times negative 3. I got it right, okay? And then I'm going to do plus 9. Now, this right here, I'm going to take half of the second number. All right? So, now, what's nice about using a half, it's either going to be a whole number or it's going to be 0.5.
It's 0.5.
Right? And this is going to be 0.5. So that makes 4 times x minus 3 over 2, which is 1.5, squared. Okay? Now, have I got that? So when I take 2 of these, I'm going to have 2 of them for x squared. I'm going to have negative 1.5 plus negative 1.5, which is going to be negative 3.0. And then I also have a third term. What is 1.5 squared? That's calculator work.
Oh, wait.
I know it, because I know that one. Right? 2.25. So I have a plus 2.25, but then I multiply it by 4. So take that number, multiply it by 4, and you have 9, and therefore I'm going to add a negative 9 to the positive 9, and I'm going to end up with 0. So now my vertex is at 1.5, comma 0, because the k is this number right here I'm pointing at, which is 0.
Right. So it's just not going to x axis.
Yeah. And then now, when you graph it, what are you going to do? Over 1, up 1 times
4.
4. Over 2, right, up 4 times 4, which is up 16, and that's all you'll be able to get on most graphs.
Right.
Okay? All right, now, so what we're doing is we're combining the vertex form of the parabola, if you can handle it. If not, you could always use negative b over 2a to get this number, and let's look at that. What is the opposite of this? Is 12 over 2 times that is 8. You notice that's 3 over 2?
Yep.
And 3 over 2 is this number right here. When I should have had a negative b. Okay? Okay? So those things all begin to work together. All right, now, is that nice and confusing as mud?
Yep.
Okay, all right.
Love it.
Questions? Questions, okay? All right, so, now let's look at 31. Let's look at 31. And you're going to say, oh, this one's easy.
No, it's probably not.
I
All
got
right?
it.
It actually is easy.
Oh, yeah.
Okay, why is it easy?
I don't know.
Huh? 31. All right, how do you create the vertex form in problem 31?
Oh my gosh, sorry.
Huh?
It asks for the symmetric point.
Opposite
Okay, all right. Symmetric point is the line of symmetry, I believe. Let's see.
Oh, there it goes.
Just going to make, I didn't bring my charger with me, so I'm just going to make it. Okay. It doesn't say here.
It's
Let's work it and see. Okay, so here we have y equals x squared minus 6x plus 8. Okay, so let's find the perfect square. All right, nicely, this is a 1. So what's going to go in there?
At
Half of
-3.
So it's going to be x minus 3. Now, what's the extra number that this trinomial will have? 3 times 3? So there's a positive 9 in there, so I need a negative 9 here. Alright, therefore this is minus 1. Now, what's the vertex?
3, negative 1.
3, negative 1. Opposite?
Same.
Same. Okay, 3, negative 1. Right now, if you wanted the solution, oh wait, I'm sorry here, then x equals 3 is the line of symmetry. Now, what's the solution? Solution is using the quadratic formula. Right? So it's the opposite of b, 6, plus or minus the square root of 6 times 6, 36 minus 4 times 8. Anybody know 4 times 8?
It's 20.
No, not today. That's 7. 4 times 8.
Today.
32. So 36 minus 32.
4.
Square root of 4.
2.
So that makes this 6 plus or minus 2 over 2a, which is 2. Alright?
Yep.
Alright, so 6 plus 2. 6 plus 2.
Is 8.
8 divided by 2.
4.
So x equals 4. And 6 minus 2. 4 divided by 2. Dose. So 4 and 2 are the two. Yeah, where's the axis of symmetry? Axis of symmetry is at 3.
Oh.
It's right in the middle of this.
Oh. Okay.
Y'all.
Now, the reason that it's only 1 point away is because of how this was set up. But if I had negative 3 and 5 as my solution, the axis of symmetry will be in the center. So what's the center of negative 3 and 5? How far apart are they? They're 8 apart, right? They're 8 apart. What's half of 8?
So it'd be
4. So this is going to be at x equals 1.
Yay! I love it. I love it so
Okay.
much. That makes
Right, because the axis of symmetry will be in the center of the x-axis between the two solutions. Okay. Now, I'm going to have to look and find out about that other one. That's a vocabulary word that he's introduced in this chapter that I'm not aware of.
It just shows up in like one of these things, and then they're like, find
Okay,
it.
where,
It doesn't tell you how.
where does it show?
178 on the example.
Okay, let me see what it shows.
Yeah, I noticed that. She got it like a
Where's that first?
Down when it shows the graph thing, it
Mhm.
has that little thing pointing to the symmetry.
Oh, okay, I see what he's saying. All right, all right, okay, now I see. All right, symmetric point. Okay, the point of the y-intercept is when x is 0, the y-intercept is 8. Right? What was the axis of symmetry in this problem? It was 3. How far apart is 8 and 3? 5. So therefore I need to go 5 on the other side of the 3. So if I have 3 subtract 5, I'll be at negative 2. So I see what they're asking. All right. That to me, again, that's another old school point. So I'll explain that now that I see it. Okay. All right. So.
I was looking everywhere for like
Yeah.
instructions.
All right. And again. All right. So let's take another problem.
Really don't like
I don't.
All right.
point is. I was like,
Squared
where did you get that from?
minus, say, 8x. Okay. All right, what's 5 and 3? 0. Okay. Now, all right, so tell me, how do you create from here, how do you create the vertex form? Because this is a 1, what, half the 8, which is x minus 4. Right? Now, what does that tell you about the line of symmetry? X equals 4 is the line of symmetry.
Right.
Okay? Now, in this problem, what happens when x is 0? 0, 15 is a point on the graph. Right? Now, how far apart is 4 from 15? So what they've done is they have this here. This is x equals 4, and right over here is 15. So that makes this 11. All right, what they're asking for when they ask for the symmetry point, they want this point right here. So take 4 and subtract 11, and you'll get -7. That's the point of symmetry they're talking about.
Right.
Now, where are we doing this? We're doing this with the x values.
Right.
Because the line of symmetry, see, this happens to be where the y-axis crosses, right? The x-axis, the symmetry is going to be here and here.
What are those two numbers on the little arrows?
11s.
Okay.
Because 15 going to 4 is 11. So if from the line of symmetry you go 11 to get to the y-intercept, then you're going to go 11 in the other direction.
Right.
Now again, I've not ever seen a use for this number.
They just like to
I have seen a use for these two numbers. Right? And so here's what would happen. Suppose that you had this number here as 3. And the line of symmetry, well, I'm sorry. This is at -3, and this is at -4.
Right.
All right? If that's true, then this other point, which happens to be a solution, has to be 1 in the other direction. And so it's going to be -5. See how it works?
Yes, sir.
Okay? All right, good questions. Are we done now?
Yes.
All right, 31. Okay, good job today. Good luck on working with this. All right, stay at it. I've tried to give you as much preview of this as I can. Remember that the test 2 question is very important, and you're going to have 2 tests to bring back to me. One will be that one I handed out to you, and the other is going to be those 3 problems, R2, R3, and the T2.
Got it.
Okay?
Yes, sir.
All right, good job.
You would.